Okay, I wanted to demonstrate how we would go about thinking through this phase plane and find corresponding trajectories. So the basic idea is we're going to follow the arrows. So as I imagine starting at some value, maybe here, we would follow the arrows and they sort of just turn around and we would come back about where we start. And as I said in class, this particular picture was designed so that we come back where we start. So we're just going to follow the arrows, and at all times we want to sort of be parallel to the arrows and come back where we started. Now if I were to take this particular orbit, this path in the phase plane, then we would want to be able to identify key points and plot them as functions of time. So what I'm going to do is I'm going to create a new graph to the side, and this is a function of time now. And we don't really know exactly the moments of time, but we do know the values of our function. So let's pick a few points and we'll see what happens. So we're going to call this our first point. We start with our p variable at 0, and our q variable at 1. So let's put a value of 1 here somewhere. So here's 1, and our q value is at 1. Now as I move to a new point, maybe somewhere here, it looks like my new p value is approximately 3. So that value went from 0 to 3. We don't know exactly what time, but we might sort of mark off a point that we'll imagine is our time. And so our p value has hopped up here to a value of 3. So this is p. Let's draw this in blue. I have steadily progressed from 0 up to 3. And that's my maximum value. And at this point I come back down, and I'm going to come back down to 0. So let's mark another moment in time, and my trajectory is going to come back down to 0, then reaches some sort of minimum state which looks approximately -3, so we'll mark that down low somewhere, which is our value of -3, and we come down and then repeat back up to our starting value, same point where we started. So that's p. Let's label that. So this is p as a function of time. If I think about what q is doing, notice the c. Q starts at this, turns out this is the lowest value of q. Q is going to steadily increase and reach a value of approximately 3. And it's going to reach it when my p variable has returned to 0. So we're going to reach a maximum when we hit this value 0. And then I'm going to come back down and reach my minimum value when I return to the first point. So that corresponds to this value at the end of my time. Okay. If I were to trace that, let's do this in a slightly different color. Let's do it in purple. Okay, there's this intermediate point here when I'm at crossing. So my curve, my q curve, maybe I should have labeled my p in a different spot there. The p function is here, the q function So that would be a trajectory, and then it repeats. So it's like this behaves a lot like sine and cosine. I'm going to reach a maximum and come back down to a minimum and then back to 0, while my Q curve is busily repeating, and so this just repeats. So that's one example of a trajectory. I'm going to draw another one now. Let's do this one in a different color. Let's see. Let's do a bright orange. Okay. What I'm going to do this time is I'm going to start on the other axis. And if I follow the arrows, notice I appear to be going around the outside. And then it gets pushed back out. And closes back up. And so this is a bit more complex of dynamics. And if I think about what my functions are doing, my p variable starts here at a value of about 2 or 3. It's going to increase to around 5, maybe 6, I guess. Decrease, steadily decrease until I reach a value of about -6 or -7. Increase to -3, then decrease again. Once I hit this value of -6 or 7 again, I'm going to increase until I reach 5 or 6, and then I'm going to repeat. So let's see what that particular trajectory would look like. I don't want to graph it on the same function as before. See, I did label t. Okay, so let's see. Here's my time variable. And let's now think about some key points. If I start, I'm going to be interested in these most extreme points. And let's just say that we get out to 6 on each way. So if I start at A, I'm going to go from, let's see, get some color here. I need blue maybe. Okay, so we're going to start. What numbers do we need? We needed 3, 6, -3, and -6. And my Q goes from -4 to 4, so that's okay. Alright. So, I start with my P variable, its vertical axis, from 3 to 6 to 0 to -6 to -3 to -6 to 0 to 6 and back to 3. So to make this curve, let's see, I start not really changing a lot, so I'm going to be need my pen. Kind of like a curve there from connecting from 3 to 6. Once I'm there, I'm going to steadily go through 0 down to -6, and then go up, bounce down, and then it repeats. So I get these. So sort of wobbles. And if I imagine where I came from, it's too far. It repeats forever, so it's not really sine or cosine because of the pulling in at the point A and its opposite point. If I now look at my second curve, my Q curve, at A, I'm at a value of 0. At the next point, I'm at about 2. And I increase all the way until I get to 4. And then back to 2. So where are we now? We're at this point. Q was 2. P was -6. And then I go to negative, what did I decide that was? Oh, back to 0, I guess. And now I get to go the other direction. So I go -2 to -4 to -2. No, to, -2 to 0. So my Q curve, it increases until I reach 4, then it decreases until I reach -4, then it increases, and it's going to repeat that forever and ever. If I imagine going the other direction, it also repeats. Okay. So if I think about my P variable as I go around the curve, my P is my Q, sorry. As I go around the curve, my Q is increasing, 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 stop at 4, decreasing, 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 decreasing to -4, increasing, and so it increases and decreases between -4 to 4 to -4 to 4. Whereas my P variable, the vertical axis, is increasing, decreasing till I hit -6, and then it's increasing to -3, decreasing to -6, increasing all the way to 6, decreasing to 3, increasing to 6. So those are how I'm getting my extra wobbles in my P variable. So let's label this. This is my P of t and my Q of t, the trajectories as functions of time. The second vector field you saw is shown here, and if I were to sort of sketch some of the orbits, so orbits are things we draw on the phase plane. Maybe it should be a little smoother there. So I get a bunch of loops. So if I follow my loops, sort of rectangular loops, except that there's a special point here on either side that sort of separates the behavior. If I start far enough to the left, I don't actually make it into a loop. I get pushed out. Similarly on the far right, if I follow a path, it's going to sort of push me. I'm going to draw some arrows here so you can see what's going on. I get these different behaviors, and if I start higher on my left axis, on the left side of the screen, and follow the path, it actually gets pushed back up, then down, and up. Similarly, if I start on the bottom right corner, I'm going to be increasing, follow the arrows, get turned around, get turned back around, go back up, and then come down. So if I sort of label the direction of motion on my orbits, I can see what my vector field is saying that I'm doing. So let's label these inside loops as well, so we get a sense of what's happening. And so these are some of the pictures of orbits. And now I want to say what kind of behavior do I have for my trajectories. So let's start. Let's see another nice Valentine's Day color. Let's do some more of a pastelish purple. Okay, so these inside loops, everything that's a perfect loop looks like sine and cosine essentially, although the shape is maybe a little different. So I'm just going to have oscillations around 0 here. I go from, for example, my q variable, x-axis, increases and then decreases, increases and then decreases, and I just cycle back and forth. So let's think about what some of these others are doing. This trajectory on the left, if I imagine where I start, my q variable increases until I cross the axis, and then I decrease, whereas my p variable is just steadily decreasing. So that particular path, let's see, my p goes, let's maybe put them on separate axes, it might be easier to draw. So here's my time and my p variable. P is steadily decreasing from 5 to 0 to 5. In our trajectory, we don't really sense what's happening after that, but I appear to just be sort of steadily decreasing. If I thought about my q variable, I probably shouldn't draw my line so long. For that same trajectory, my q at this first point is at -5 to -3.5 maybe. So -5, -3.5 to -5. So if I want to draw that, maybe I should have put my axis up higher. So I go from -3, -5 to -3. My q variable presumably is going to just keep... Oh, I did that backwards. -5 to -3 to -5. I increase, then decrease, and then presumably would continue on, whereas my p variable looks like it's just steadily decreasing. And so that corresponds to this first curve. Alright, let's do another one. Let's ask, if I start on this upper one, the main important points appear to be these 5 points that I've marked in orange. So let's think about that particular path. What is p doing? P is going maybe 8 to 4 to 8 to 4 to 8. So if I were to draw my axes, my time, my p variable, I'm going to go from 8 to 4 to 8 to 4 to 8. And now I can draw my curve. We expect some sort of oscillation. 8 to 4 to 8 to 4 to 8, and then it appears that probably just is going forever. Now what happens to Q? My Q variable is steadily increasing from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So my Q variable for that same picture appears to be steadily going from -5 to 5. Let's see, we're in orange. So -5, that first point appears to be -3, 0, 3, and 5. Maybe there's some sort of wobble, but we can't see it from our picture. But my Q for this second path is just steadily increasing. If I imagine some other paths, let's see, I've got a path here, so what's happening? My P is steadily increasing, but Q decreases, then increases. So I get these different behaviors by imagining my points. Now the speed, how fast it's going, changes the curve. So we might not get a straight line. I might actually wobble as I take that path. This is the idea of a vector field and finding trajectories based on the field.